Alright guys, so today we're going to be doing some limit problems. We start off with our first problem right here. Limit as x approaches 2 of x squared minus 3x plus 2 all over x minus 2. Here's the thing with this question. If I try to substitute in number 2 into this equation, it's not going to work essentially. Because you're going to have some number over 0. And that's not going to work. So, do we have like a different form? Like, can we factor it? Some of the strategies we use are factoring and canceling. Okay. We have rationalizing. The num or denominator. Okay. We have, I'll make sure you guys can see, using trig identities. Okay. We have calculating left hand limit and right hand limit. See if they equal. Okay. And we have factoring the highest power of x. From the numerator and denominator. Those are all the options: factoring, canceling, rationalizing, using trig identities, calculating left hand limit and right hand limit, and factoring the highest power of x from the numerator and denominator. So those are all options. So this one, it seems what we can do is actually just factor. So we need a product of 2 and a sum of -3. So that would be product of 2 and a sum of -3. 3 and -1, or 3 and -1 would give you 2. Did I write the question down wrong? Three and -1 should work as well, because 3 plus -1 is 2, and then 3 times -1 is -3. It seems like what they did is that they used -2 and -1. So what happens is that when you have the limit as x approaches 2 of x minus 2 and x minus 1 all over x minus 2, you can cancel those. You have the limit as x approaches 2, x minus 1. So what happens then is if you put in 2, you can actually evaluate now. You would make something that's undefined. So you'd have 2 minus 1, which is 1, is the answer. So that's how you would do that. And when you actually evaluate it, that's when you get rid of the limit, essentially. Okay? So let's look at question 2 right here. All right, so with question 2, we have is limit as x approaches infinity of 2x squared plus 1 all over 3x squared plus 9x plus 8. Okay? Thing is, and that's a squared by the way, pardon me. Thing is, we want to factor, this is the one strategy where you want to factor the highest power of x in the numerator and denominator. So in this case, it'd be x squared. And when we do that, we get something along the lines of this. So we set the limit as x approaches infinity of x squared 2 plus 1 over x squared all over x squared, 3 plus 9 over x, plus 8 over x squared, essentially. All right, so what happens is that these will cancel the limit as x approaches infinity. And you have 2 and 3 just hanging out. You have plus x squared, and then plus 9 over x. So what happens is that, like, logically think about this. If you put a big number on the denominator, it's going to become 0, this value. And what you're left with in this fraction is 2 over 3. So this becomes 0, and this will become 0, and this becomes 0. And you're left with 2 over 3. So your answer ends up being 2 over 3 when you evaluate it. So that's when you want to just factor out the highest denominator, highest power of x, the numerator and denominator, using that strategy right there. Sweet. Let's try to do another example right here. Is that the same thing for 3? I think 3 is the same thing, so we'll try 4. So if I go limit as x approaches pi over 2, the sine of 2x over cos x, right? You put pi over 2 gets sine of pi over cos of pi over 2, which is 0 over 0. That's not good. So we're going to use a trig identity up our sleeve and trying to solve this problem instead. So what we can do is know that sine 2x, so we still have the limit as x approaches pi over 2. Sine 2x is 2 sine x cos x all over cos x. So these cancel. And what happens now is that you have the limit as x approaches pi over 2 of 2 sine x. So you can go ahead, you know that when you actually evaluate the limit, that's when you stop right at the limit, and you get this 2 times 1, which is this 2, as your answer, essentially. So your answer would be 2 times 1, which is 2. We're almost done, guys, don't worry. We have a couple more examples. Maybe perhaps we'll rationalize a numerator denominator. Don't know. So let's say the limit as x approaches 4, root x minus 2 over x minus 4. You rationalize the numerator. Okay? So we do root x plus 2, root x plus 2. Okay? So we're still going to write the limit as x approaches 4. X times, well, root x times root x is x. Those will cancel. The root x is like negative 2 root x, excuse me. And that'll be minus 4 all over x minus 4. Root x plus 2. So lo and behold, these cancel. And I get limit as x approaches 4 of 1 over root x plus 2. So if I put in 4 right there, I get 1 over root 4 plus 2, which equals 1 over 2 plus 2, which equals 1 over 4. So that'd be your answer for that one. Absolute values. Thanks for coming back. Now, a lot does in calculus. So the absolute values, what we're going to do is we have the limits as x approaches 0, the absolute value of x over x. Okay? So it's like a piecewise. So the absolute value of x is equal to, big kind of bracket thing, is minus x for x is less than 0, or x for x is greater than equal to 0. Okay? Because it'd be minus x if it was negative, and it'd be x if it was greater than equal to 0. So meaning that the limit as x approaches 0 from the left side is x over x which equals negative x over x, which equals -1. That's the left-hand limit. And we do the right-hand limit. So limit as x approaches 0 on the right of the absolute value of x over x, which equals x over x, which equals 1, which is the right-hand limit. Now the thing is, because the left-hand limit does not equal the right-hand limit, that means the limit does not exist. So because left-hand limit does not equal right-hand limits, indeed the limit dne does not exist. Thanks so much for watching this one, guys.